2. Now the biggest thing you got to realize, I'm hoping you're picking up on this, is the absolute value ones are the ones now where we're going to actually test values to shade. So looking at this problem, there's a 6-step procedure that we talked about in class, and I hope you have your notes with you because that should really help you through this procedure. I will kind of speak it through. The first thing is you got to make sure that the absolute value is alone on one side. Since it is, I'm going to take this blue pen here and I am going to box it. I've been kind of talking about that, just box it. Well, that's kind of nasty, but get a box around it. That's where we're going to test, okay? So eventually when we're at the testing phase, this is where we are going to test. All right, I'm not ready to go there yet. What I'm going to do is I'm going to get into pretend land here. So we'll do that in green. I have you really think about this problem as it said absolute value of x plus 6 is equal to 10. If so, you should know how to split and get your two answers. So x plus 6 equals 10, or x plus 6 equals negative 10. And when we subtract 6 from both sides, we're going to get our two values here of 4 and negative 16. Now 4 and negative 16 are my boundary points, so I'm going to put negative 16 here, and I'm going to put 4 right there. And now I'm ready to test. I mean, after all that work, I am ready to test, shade, and put it in interval notation. You can pick any value. If we pick a 0, 0 is one I like to choose a lot. It's in the middle region here, okay? So if I test 0, I'm literally putting it into where I said test. So 0 plus 6, the absolute value of that greater than 10. I'm just looking to see if this is a true or false statement. 0 plus 6 is 6. The absolute value of 6 is 6. So 6 greater than 10, is that true or false? In my book, that would be a false statement. So that's false. So that should get you thinking about these other regions. If we test 5, 5 is in the right region. 5 plus 6 greater than 10. Well, when we work this out, we will get 11 greater than 10, which is definitely a true statement. Over here in this region, if you test, say, negative 17, and you add 6, and then you compare that to being greater than 10, you're going to get negative 11. But it's the absolute value of negative 11. Make sure you're careful about that. So that would make it a positive 11 greater than 10. So that is a true statement. We shade the trues. So what I'm going to do is I'm going to grab, let's see, I've used all these colors, so we'll go back to black. Looking up here, if I could highlight this, right there is where you look. So what we want to notice there is it says greater than, not, or equal to, so it's a parenthesis problem. So we're going to use our parenthesis here, and we're going to shade the true region, put an arrow on the end. Over here, we're going to shade the true region. So what this is going to be in interval notation is negative infinity all the way up to negative 16, union 4 to infinity. All right, this one, all the rest of these are exactly the same type of problem, but the first step is to get the absolute value alone, like we already had it in part A. So I'm going to go a little quick here. We're going to subtract 8 from both sides. After I subtract 8 from both sides, I'm going to have that. Remember, you don't want to put the 8 and the 2 together. You want to subtract 8, so we have here. Now we're going to divide both sides by 2. So dividing by 2 cancels here. Dividing by 2 makes a 4 on the right side. So absolute value of x minus 5 is less than 4. And I'll grab the highlighter this time. This is, whoa, sorry. Now I have the highlighter. This is where we're going to test, okay, at the end of this problem, right in that highlighted area. Okay, so I'm not ready to go there yet. I need to pretend that it says equal. And now I'm running out of room, so I'm going to go up here. So now we split x minus 5 could be 4, or x minus 5, running out of space, could be negative 4. So adding x to both sides, we're going to get 9. Adding 5 to both sides, we get 9. And adding 5 to this negative 4 is going to give me a positive 1. So my two values here are going to be 1 and 9. And then I test my regions. Okay, so testing my regions, once again, we want to test right back in there. That's where we're going to test. Okay, so testing 0. Oh, be careful. If I test 0 on this problem, 0 is actually in this region over here. So when I test 0, that's going to be 0 minus 5. And then I'm looking up at the highlighted part here, less than 4. So that's actually negative 5, but when we take the absolute value, it's positive 5. Is positive 5 less than 4? That's a false statement. All right, if you test the number 10, 10 minus 5, is that less than 4? Well, that's going to be 5. Absolute value of 5 is 5 less than 4. That's still a false statement. We pick any value in here, let's say 6. So if I test 6, 6 minus 5, is that less than 4? 6 minus 5 is 1. Absolute value of 1 is 1. There's where we get our true statement. So that's going to tell us where to shade. And this problem, if we look, does not, again, have the or equal to, so it's just going to be parentheses. But this time we're shading, sorry, on the 9 there. This time we're shading the middle. So interval notation would be 1, 9 on that problem. All right, halfway through this worksheet. On the back side here, first thing we're going to do on this problem is to divide both sides by 4. All right, so the first thing we have is dividing by 4, not distributing the 4. That's what we do not do with absolute value. Absolute value of x minus 6 is less than 6. I'm going to pretend, I'm going to go a little bit faster now. X minus 6 is equal to 6, the absolute value that is, split. So I'm going to get x minus 6 equals 6, or x minus 6 equals negative 6. And I'm going to add and get x equals 12. And over here I will get x equals, adding 6 to both sides, 0. So my 2 points here are 0 and 12. Only difference on this one is when I test, I can't test 0 because it's now a boundary point. But I'm going to go right back up here and I'll test maybe 4. 4 is in the middle here. So if I do 4 and put that in, I'll get 4 minus 6 less than 6. And then I'll say, okay, that's negative 2. But the absolute value is positive 2. So 2 is less than 6. That is a true statement. So since it's true, I know I'm going to be shading in the inside here. These two, when tested, will both come out to false. I highly encourage you to try those, but they will come out to false. And again, I do not have brackets on this problem, parentheses, so 0 to 12 would be the answer to that one. All right, finishing strong here. We got to subtract by 5 first. Trying to give you different scenarios to get the absolute value alone. So we now have 2 times the absolute value of 2x less than or equal to 30. And at this phase, we want to divide by 2, and it only divides with that number out front. So we have the absolute value of 2x is less than or equal to 15. All right, now that is where I'm going to test in a little bit. All right, so moving along, pretend land can be in green here, let's say. So 2x, absolute value of 2x is equal to 15. That's what we're pretending. And then now we do our split. Remember, the inside part, 2x could be 15, or the inside part, 2x could be negative 15. When I divide both sides by 2, I get x equals 7.5. And when I divide that one by 2, I get negative 7.5. So the negative 7.5 is going to go here. The positive 7.5 is going to go there. And let me get to a different color here. Maybe blue would be fun. Test my values now. 0, again, is an easy one to test. I like testing 0. So literally in blue here, if I put a 0 into here, I'm going to get the absolute value of 2 times 0. Sorry, that doesn't look the greatest. And I'm less than or equal to 15. So 2 times 0 is 0. Absolute value is 0. So basically, is 0 less than or equal to 15? Sorry, I wrote that wrong. Less than or equal to 15. I'm getting a little sloppy here at the end. Sorry about that. 0 is less than or equal to 15. So that's a true statement. So this is a true region in here. If we test 8, once again, that would be 2 times 8, or the absolute value of 16, less than or equal to 15. 16 is not less than or equal to, so that's going to be false. And if we test this region, we'll also get a false. This one, though, if you look up here, actually has a bracket. So we have to do brackets around these two values. And again, we're shading the inner part. So it'll be bracket negative 7.5 all the way up to 7.5 with the bracket. Okay, I hope this video helped. If you need more help, make sure you're communicating that to us. And good luck on your test. I hope it makes you smile.